Okay, so what is Newton's method? Newton's method, it helps you to estimate, is used to estimate the solution of fx equals 0. Okay. So here, because you want to estimate fourth root of 2, this is the root of, fourth root of 2 is the solution of x to the power 4 minus 2 equals 0, right? So you want to estimate this. It's same as you want to estimate the root of this equation. So we can just use the formula. We start from the point x0 is 1, right? Then the Newton's method, xn plus 1, it's xn minus fxn over the derivative at this point. Okay, so fx is x to the power 4 minus 2, right? F prime x is 4x cubed. So now x1 is x0 minus fx0, right, over f prime x0. So it's 1 minus f1, right? f1 over the derivative at 1. Okay. So this is 5 over 4. Okay, then x2, it's the same. It's x1 minus fx1 over the derivative at x1. So 5 over 4 minus 5 over 4 to the power 4 minus 2, right, over 4 times 5 over 4 to the power 3. So you do this calculation, it is 1.1935. Okay. Problem 7. It's also the Newton's method. So now the function is x cubed plus 2x minus 4. Right? So the derivative is 3x squared plus 2. Find its root in 1, 2. Then, okay, first you have to use the intermediate value theorem to prove that it has a root between 1 and 2. So first, fx is continuous because it's a polynomial on the interval 1, 2, right? On the closed interval 1, 2. And second part, f1 is what? f1 is this. It's negative 1. f2 is this. Is 8. Right? So f1 is negative, f2 is positive, which means by intermediate value theorem, okay, there exists a root between 1 and 2. Okay, so this is the first part, to prove there's a root. And the second part, you just have to use Newton's method to approximate, right, to 5 decimal places. So let's see how to estimate to 5 decimal places. Let's copy fx here. So first, we don't have a starting point, right? We don't know what is x naught. So we can just set it to be 1 or 2, right? We can set it by ourselves. For example, we let x naught is, right, x naught is 1, right? Then x1 is x naught minus fx naught over f prime x naught. Okay, so the calculation is yours. It's 1.2. So the question asks us to use it to find the root to 5 decimal places. So to 5 decimal places, that means when your xn is something dot something, right? Your xn plus 1 is something dot something. Then the first 5 decimal place must be the same, right? These two must be the same. So 5 decimal places must be the same. Then we can say this is our solution. Okay. So we have to do it until the first 5 decimal places are the same numbers. So x2 is, x1 minus this. So you can just keep the calculation by itself. So f2 is 1.179747. x3 is this. Okay, it is approximately 1.179509. So you can see here the first 3 are the same, right? But the fourth are different, so you can't stop here. We want all these 5 decimal places to be the same. So x4 is this. Okay, it's 1.179509, right? So now the first 5 decimal places are all the same. Okay. So now we can stop here. Now we can stop and we say that a solution is approximately, so then the solution is approximately 1.179509. Okay. So this is about the Newton's method.